So, upon review of my dummy load project, I'm pretty happy with how this turned out. I can't complain. Um, the one thing to keep in mind is I don't want to put a whole lot of amperage through this, especially for a very long time. Even though it does have a fan and a heat sink on it, it's still going to heat up. I wouldn't want to put, 4 or 5 amps through this box for an extended period of time. Turning it on, putting, 3 or 4, maybe even 5 amps on there just to measure the load, and then turning it off after, a very short amount of time would be all right. But I wouldn't want to start running, 3 or 4 amps through this for several minutes at a time. It would end up getting rather warm. Now, if you have been watching the other videos that I put up on YouTube, you would have seen me mention the power converter. And my intention is to essentially reverse engineer this power converter. This one is broken. It was working when I got it. It's no longer working anymore, but it's a little power converter by a company called Drock. And it's a pretty basic layout, pretty standard according to the data sheets for the ICs that are involved. And what I'm going to be doing is I'm going to be taking this circuit board apart, and I'm going to be examining how it's constructed under a microscope, and then essentially reverse engineering how the circuit board is put together, and then also using the data sheet to guide me on putting it together. One thing that I'll have to do is get significantly better with KiCad in regards to heat sinks. I was initially thinking about etching my own circuit board for the dummy load. However, I found that I had some difficulty kind of defining where a heat sink would be, which makes it a bit more of a challenge. And also, I wasn't quite sure if I would be able to get away with using a double-sided circuit board for this. So yeah, the next thing is going to be tearing apart this broken circuit board, looking at the circuit board under the microscope to get a good idea of how it works, using a data sheet to help me plan out construction of another power converter, a buck converter, and then designing my own circuit board and etching it, putting it together, and testing it with my dummy load to see what kind of characteristics I'm actually getting off of it. And I could, I have another one of these on hand that actually does work, and I could test that against my dummy load as well, which I may do just for, just for a comparison. So as far as the buck converter, the reason I'm wanting to get into this is, number one, for an exercise in reverse engineering, just to, see if I can, tear apart the circuit board and, make something comparable. Additionally, it's because I am eventually wanting to create projects that are going to be battery powered, and using a linear regulator off of a battery is horrendously inefficient. If I can incorporate a buck converter onto my circuit board, then I will have a very efficient power converter, which will help extend the life, the charge on the battery, so I get a greater amount of useful work. At this point, that pretty much wraps up my dummy load project. Kind of started out with a couple of different ideas, tested out some some circuitry on the breadboard, made some changes, decided there were a couple of things I didn't want to do, and then ultimately put it together on a proto board, put it in a box. There's a lot of glue involved with this. The fan is glued on, or glued to the inside of the box. A couple of wires are glued to the side of the box to keep them out of the way, and then the resistor and the barrel jack, I had to use glue to hold those together. The switches here, they're just held with their own little nuts. They come with a couple of nuts to hold them in place. The ammeter just snapped into place. The terminals, they just screwed into place. They have nuts holding them. And then it's the same for the potentiometers. Potentiometers are soldered straight onto the circuit board, so that is what's kind of providing the mechanical support to the circuit board to hold it in. But there's nothing else that's putting any weight on it or interfering with it. So this is a a nice little piece of test equipment that I'll be able to use. Not horrendously fancy. I'm not going to be able to use it for everything, but certainly this will be effective for testing. A power converter that if it puts out an amp or an amp and a half, I should be able to test it effectively with this. If I'm putting out 4 or 5 amps, I can hook it up, test it for a moment just to verify I am in fact putting out the amperage that I think I am. So yeah, really happy with that. The next thing that we're going to be doing then is moving into reverse reverse engineering, or at least tearing apart and examining this power converter from Drock to then see about working